So good day to everyone. Welcome to a new webinar from the Science webinar series. This is the second edition on the topic of climate change. And this webinar series are jointly organized by the YES working groups, on one hand, the online events, and on the second hand, the Science working group. And before going to the presentation, please, Juan, if you can go to the next slide for the code of conduct. So I would like to present the YES code of conduct for this webinar. Please be polite and respectful to the speaker and for all the participants. Please keep muted and close video during the presentation. I will ask you also that you can type your questions in the chat box during the webinar, and we will have also a Q&A session after Juan finishes his talk. And then just to let you know that we are recording all the contents, both the presentation and the questions in the chat box. So today we are going to learn about the water resources change in Central-Western Argentina under the Paris Agreement warming targets. The speaker is Dr. Juan Rivera. He's a researcher from the National Council of the Scientific and Technological Research in Argentina. He's working at the National Institute for Snow and Glacier Research in Mendoza, a province in Argentina. And he received a PhD in atmospheric sciences from the University of Buenos Aires for his research in drought characteristics over southern South America. He's also currently lead author of the Working Group 1 of the IPCC 6th Assessment Report. And his current research is focused on hydrological drought dynamics over the central Andes of Argentina and the impact of climate change in the hydrology of the region. So welcome, Juan. It's a pleasure to have you here. And thanks for accepting our invitation to participate in this webinar series. And please go ahead for your presentation.
Okay, thank you, Carla. Thanks for the invitation. Good morning, good afternoon, good evening, wherever you are. Well, I will talk about some climate change issues in Central-Western Argentina. This is part of a preprint that we submitted to Frontiers, some of the Journal of Frontiers, Frontiers in Climate. I want to acknowledge also my co-authors, Elizabeth Naranjo Tamayo and Maximiliano Viale, also from the National Institute for Snow Research in Argentina. So we had some motivation and objectives I want to share with you. For those who are not familiar with the Paris Agreement, in the year 2015, the Paris Agreement broke the United Nations Framework Convention on Climate Change member states to put forward actions to limit global warming well below 2 degrees above pre-industrial levels and to pursue further efforts to limit the average temperature increase to 1.5 degrees compared to pre-industrial levels. Argentina signed this agreement in 2015 and ratified in 2016, committed to a reduction of greenhouse gas emission by 2030 that represents 18% relative to 2010 values, plus an extra reduction of 18%, so would be like 36% in total by 2030 if the country receives international economic aid. So my main question were, how much longer will it take to reach the Paris Agreement warming level? What impacts these increases in temperature will generate on regional hydrology? And if are the national goals regarding the emissions reduction sufficient? So I wanted to provide a regional view of this global warming problem. I'm aware that the warming levels are used to be calculated on a global perspective, but I wanted to go deep into a regional perspective and to see taking a target area as Central-Western Argentina to see what kind of impacts can we expect from these warming levels. So the study area, for those who are not familiar with the region, is located in the Central-Western Argentina, close to the Andes ranges, in the limit with Chile. This region is famous because the wine production. So if you go to a supermarket and you go to the red wine area, you pick up a bottle and you will most likely find a label saying products from Mendoza. So this is where we live and where we develop our research activities. And for this wine industry and the rest of the agricultural activities, most of them are extremely dependent on irrigation, and irrigation is also dependent on the amount of snow that falls in the Andes during the winter season. So you can expect that a large variability in the snow amount will impact also in the stream flows over the region, and of course in the industrial and agricultural activities over the region. Just to summarize some of the data and methods, we used the IPSL version of the semi-arid model experiment. We use it. This model has a large ensemble of simulations, so we use it for the historical period, 10 out of 32 members, to calculate these warming levels and the historical evolution of temperature and other key variables. Given that we are going to be focusing on the Paris Agreement target levels, we focused only in the scenarios that had strong mitigation tools or mechanisms. So we used some of the scenarios that are not widely used in the scientific literature, as the SSP1.9, 2.6, and 3.4. That represents, of course, the most optimistic scenarios in terms of global warming and in terms of concentration of CO2 emissions by the end of this century. We considered as a pre-industrial period the years 1861 to 1890, and the control period to characterize the climatology of the region in 1981 to 2010. And we used the delta change method to calculate the changes in the different variables of the hydrological cycle, as the difference between the variables in a period where the temperatures reach 1.5 degrees above this pre-industrial period, or 2 degrees above this pre-industrial period, minus the control period. So in order to say why we selected the IPSL model, as a team, we are involved in an international project called THEMES, the Mystery of the Expanding Tropics, funded by the Paribas Foundation in France, that wants to understand the expansion of the tropics. And we live just in where the descending branch of the Hadley circulation of the Southern Hemisphere is located. So we wanted to understand from a long-term perspective the changes in the circulation patterns and the impacts in the hydrology of the region. And of course, using 3 rings to characterize the long-term past variations, and also future projections to characterize what kind of impacts can we expect in terms of changes in the hydrological cycle or increases in temperature. And we also had the chance to make some validations and to use this model before, just to understand how the model represented the dynamics of climate circulation over the region and some of the components of the hydrological cycle, particularly precipitation over the study area. So we have been using this model for a couple of years ago. And also we rely on several recent publications that uses also this model. I can mention this recent published paper by Fernanda Cabrera and Mario Núñez that uses the previous version of the model, the one from SSP5. And it's also interesting that this model was one of the best among several models that were used for the national communication to the UNFCCC. So we were confident that this model could give some nice overview of the climate of the region and its changes in terms of the water cycle. Just to summarize the current drought situation in the region for those who are not familiar, we are facing now one of the longest and most severe drought conditions in the whole record. Here in the upper left, you can see the in yellow to red colors the periods where the stream flows were under drought conditions from 1971 to just 2 months ago. And in the upper panel, you can see the time series of standardized stream flow records. You can see that in the last 50 years, this condition, this period of 10 years on a row with drought condition is unprecedented in the last 50 years. You can see the water level reductions. This is a shallow lake in southern Mendoza, which faces also a reduction of stream flow contributors and a reduction of size with all the implications for the ecology of the region. Also, some colleagues published recently the changes not only on stream flow, but also on snow and ice glaciers that were shrinking during the last decades, particularly this period between 2009 and 2018 was really dramatic for all the ice bodies in the region. Not only in central Andes, but you can see also in the southern Patagonia that the loss in the ice was really significant. And this is a comparison for the snow coverage in the Andes of Mendoza in a normal year and in a dry year. You can see that this reduction is significant and also have impacts for all the hydrology of the region. And if we go to the long-term perspective, we have some really interesting records covering more than 100 years of records for the stream flow of the regions. Here is just an example for the Mendoza River that you can see this decline in stream flow in agreement with this recent decade of drought, which is unprecedented in the history of the last 110 years. And of course, this has and also is currently having a lot of media coverage because makes you think that we are facing something unprecedented, and this is also part of the motivation in order to see what kind of future we are going to expect in terms of water resources for the development of all the agricultural activities, and also for water supply for human consumption. Just to summarize first of the preliminary results, this has not been published yet, but I'm confident that we are going to publish very soon. We had the first round of revisions just last week, and I'm very optimistic about this paper, this manuscript. First, in order to see how many time do we have for before getting into these warming levels established in the Paris Agreement. First, I wanted to make a distinction between the Andes and the lowlands. I want to go back a bit further. The Andes will be this area where the highest elevation and the lowlands is this other area where we have less elevation. And so with this distinction, I'm making use of two scenarios, the 1.9 and the 2.6, one of the lowest one among all the scenarios available. To calculate this, what we did is to first you will see a black line, which is the 30 years average of all the temperature over the region. So we took the pixels covering the Andes, and we calculate the warming relative to this pre-industrial period, which was 1861 to 1890. And we merged it with, of course, the historical runs run until 2014. So we merged it with the future projections under this scenario. And we established the time or the year by where this temperature will overpass the warming level in the Paris Agreement. So for the Andes, for both scenarios, we will reach the 1.5 degrees warming level by 2020, which should be this year. Of course, I wanted to just remind you that we are using one single model. We should expect a bit of spread if you use more models, but I'm confident of this period of years, maybe plus or minus 1 or 2 years, but sounds reasonable. And the 2 degree warming level will be reached by 2042 for the lowest emissions scenario, and 2038 for the 2.6 emissions scenario. So you see that when you relax the mitigation actions, you can face an early peak in particular in the 2 degree warming level. And you can see some kind of overshooting when you see the evolution of the temperature that could be attributed to the mitigation actions in order to reduce the increase in temperature that is not quite evident in the 2.6 scenario. And of course, we wanted to select these ones and not the commonly used 4.5 or 8.5 scenarios, because we wanted to see how realistic would be an increase in how early can we, how much time do we have, because to make actions to avoid this. And if pushing so hard and using the mitigation scenarios you can see that we don't have much time. So using the 8.5 or the 4.5 will usually give you even less time to reach these warming levels. And in terms of the lowlands, you can see that in both cases, you don't reach the increase in temperature above 2 degrees compared to pre-industrial level, which is good because the mitigation activities worked somehow, but we are not avoiding to reach 1.5 degree, which could be reached by 2035, more or less, in both scenarios. So another interesting thing is a differential warming between the Andes and the lowlands. Maybe the lowlands is more in agreement with the global timing of uh, these warming levels. Those results were published in the special report of 1.5 degrees by the IPCC, which has more or less this year as a key year for reaching this 1.5 degree warming level. Um, so it's interesting that all the water resources that are originated in the Andes will face an even faster increase in temperature, and so that will push the water resources to be more limited for the population and for the agricultural activities. Just to illustrate that this is not really recent in terms of the temperature increase, the impacts about this. You can see this trend in warming since pre-industrial era, since 1850. And of course, the glaciers, we have some documentations based on photographs and other kind of documents that illustrate a glacier retreat, both in the Chilean side of the Andes and also in the Argentinian side of the Andes, with a sustained reduction in the ice bodies. Here we have a more recent picture where you just can compare the last 30 years and you can see this kind of difference in the glaciers. So it's really shocking when you see or when you realize that the glacier could be reaching some large areas that are now not covered by ice. And this also was a nice motivation for the first national glacier inventory for the region, which is also taking it's also being developed by my institute. So this global warming has really a strong impact in all the hydrological cycle over the region. So you might expect that with these increases in temperature of the region, we might find some reductions in all the components of the hydrological cycle. Particularly, we analyzed the snow area percentage and the snow depth. You can see that all the for the three scenarios used, we can see a significant reduction of between 10 to 30% for the nose area percentage, which is also more significant considering the 2-degree warming level rather than the 1.5 warming level. And also the changes in the snow depth would be between 15 to 40 percentage. So just as a reminder, this was calculated between when you cross the warming level of 1.5 or 2 degrees, you have to take 15 years. You have to take that year as a central window of 30 years. So you have your period. For instance, the 2.0 degrees for the 1.9 scenario would be 2042. That the the period of analysis will be like 2028 to 2059, more or less. So you have to take 30 years with this as a central year, and to compare with the control period, which was 1801 to 2010. Some of the published literature also wants to compare the complete human footprint of the global warming. So uh, what you do is to calculate these future periods. Com- you calculate the delta between the variable in the future period minus the pre-industrial period, but we decided to give that will give you an even larger numbers, and we didn't want to alarm the decision makers, and it was also more difficult to understand or to explain what was pre-industrial for for a person who is not familiar to global warming or climate change. So I think this this future these relatively short periods of in the future minus the control period could give a, a relatively understandable numbers for mostly for the decision makers in the region. And of course, if we consider the snow amount anomaly, you see a decline in this variable for the three scenarios. And also, as I've shown before, given the strong dependence on stream flow to snow and ice, you might expect a significant reduction in the total runoff and also the surface runoff over the region. So we see for these two warming levels a reduction in the three scenarios. Uh, so we will face not only a reduction in the snowfall, but also a reduction in the water available that originates mostly from the snow that fall in the winter. And considering the dynamics of this this kind of reduction, uh, we were aware that some of the component that could explain this would be an expansion of the Hadley circulation, considering that the descending branch can be interpreted as the position of the anticyclone, as the semi-permanent anticyclone in the mid-latitudes of the southern hemispheres, particularly over the Eastern Pacific near Chile. So what we did is to calculate some metrics for the Hadley circulation expansion, and we did the same as we did for the variables of the water cycle. We considered the period in the future where the warming levels will be reached, and we calculated the data based on the current period, on the control period, and what we see is of course an expansion that might not be significant, but indicates that the position of the anticyclone will keep moving towards the south in all the scenarios and considering all the metrics. Um, and this implies that if the anticyclone is moving towards the south, um, the storm tracks will be pushed to move southward also. So the winter storms will not be able to reach the latitudes of the central Andes, and therefore will contribute to a lower amount of snow over the winter seasons. And of course, this will imply a reduction in the runoff uh, that will um, also impact in the irrigation activities of the region. Uh, so just to summarize, one of the main findings of the study, we we see that, or or, or our results show a reduction. Or first of all, an increase in temperature will be even uh, warmer in the Andes rather than in the lowlands. Uh, this will contribute to a reduction in snowfall and the snow coverage in the Andes that will contribute to a reduction in runoff. And probably this will increase the irrigation demands over the region, particularly in the foothills of the Andes, which are really dependent on irrigation from the rivers. And I didn't give much detail about the lowlands far in the east, which that doesn't depend from the snow in the Andes, but depend more on the rainfall. I didn't show, but it is expected an increase in precipitations over this region, which will increase also the runoff over the area. And the irrigation demand, I put two arrows because I'm aware that should be going down if we have more stream flow and more rainfall. But um, also, I think that if the evaporative demand will be even larger, and also the areas designated to the crops will increase, facing the increase in population. And so I think this will be even complex to get the irrigation demand over the lowlands. But what is clear is that the hydrological cycle of the Andes will face uh, conditions that uh, will will demand some uh, better management of water that will be even limited in the future. And just to to give some final considerations, given that this paper was thought about making a discussion about the Paris Agreement, we wanted to also discuss about the available options that we have, or at least the country have for decarbonization. Uh, we are facing a global problem, but we can think that Argentina has the potential to make a significant contribution to reduce these CO2 emissions. And looking to the publication from Arango Aramburu et al. From this year, you can see that comparing with countries as Uruguay or Chile or Brazil, the the installed wind capacity in Argentina is really low, and we have the potential in both in the Central Andes, in the Sade area, and particularly in Patagonia to improve this um, the generation of wind energy. And if you see also the solar energy, you can see that countries as Chile, Brazil, Peru, Uruguay, Ecuador are way above the installed capacity of Argentina. And when you see also the Central-Western Argentina, you might think that there is an enormous potential to improve these two kind of energies that can help decarbonization in order to achieve the Paris Agreement. And also considering this paper by Santos da Silva that um, he he projected the changes in the land use and the use of water. You can see that the projections for the next 30 years indicate that a reduction in pastures and other natural lands uh, to the expense of cropland and forest, and particularly this increase in croplands, if we take a look of the changes in the use of water, you see that most of the change will be an increase in water for irrigation. So we are not really, I don't know how to say, but I don't think we will have enough water to supply the demand for an increase in the cropland areas. And particularly in Central-Western Argentina, there is a problem because the agriculture is not relying it's not rain fed, and it's based on irrigation. The problem is regarding irrigation efficiency. So I put the two interviews that came out in the media here in Mendoza, that saying that the irrigation efficiency is not even 40% in the southern portion of the province, and to reach to an efficiency of 60% will require 1.2 million, $1,200 million of investment. So I think water will be a limited resource in the future, and we have to start thinking how to improve the use of water that we are currently using for the agricultural activities and water supply for human consumption, and then to think about what kind of future we are going to face in terms of these projections. Of course, this was a preliminary study, but we can provide a more broadened options to see to aid the decision makers and to illustrate the current situation, the future conditions that we're going to face, and to say, okay, the limited water we demand, that we have to be or to make a better management of this limited resource. So I'm open for questions, and I want to thank you for your time.
Thank you very much, Juan, for this insightful and relevant presentation. Now we will move on to the Q&A session. So you are all welcome to type your questions for Juan in the chat box. We will wait just a few minutes in order to receive the questions. In the meantime, if I do not see any questions, I have a question for you, Juan. Are you in contact with the stakeholders in Mendoza province and decision makers, or how do you plan when this paper hopefully would be published? How do you plan to communicate these relevant results and the importance for taking mitigation actions as soon as possible?
Yes, thank you. Yes, we are in contact. I will give more or less the same talk in Spanish in 2 weeks to the mayor of the city of Mendoza in a forum of climate change and water resources that is organized in some in a university, Juan Agustín Maza. So I think as a scientist, we start to think first. As a researcher, I wanted to solve relevant problems to the society, and of course, here in a semi-arid region, which depends highly on stream flows, I think it's relevant to understand what kind of future will face these water resources, and some of the tools that I thought that will be useful to communicate this is, of course, to try to analyze these kind of problems that we've been identifying in the region, like the irrigation efficiency, and to say, okay, the resource will be even limited in the future. This is where you have to push for a better management of water, and also to try to make stakeholders understand that maybe the decarbonization pathways are possible here, particularly in the Central-Western Argentina, in terms of these two kind of alternative energies, solar and wind power, that have, I think, enormous potential to provide clean energy for the region.
Thank you, Juan. There is a question from Leandro Diaz. Thanks for your nice presentation, Juan. And the question would be, in which extent do you believe that population in Mendoza, San Juan, etc., are aware of this kind of problems for the near future?
Well, I think they are aware because we had a problem also with minery over the Andes, which uses a large amount of water and also contaminates some of the river courses, particularly in the San Juan province, in northern portion of the Central-Western Argentina. So at least here in Mendoza, people is really against minery and destruction of minerals, which is it's not always done on taking care of the environment. So I think people is and particularly this last the period that I shown, this last 10 years of drought, people started to think that the water resources in Mendoza or in the Central Andes are a limited resource. When you start or when you see the parks, we live in an irrigated area, and we used to think all the parks green in the summer and the people playing there, but water needs a better use in terms, and I think the priority is the human consumption and the irrigation activities for the agriculture. So I think people is starting to realize that water is a limited resource in the region, but took took 10 years of drought to make people understand this.
There is another question from Cass Richards. Hello, thank you for sharing your work, Juan. What follow-on questions for future research do you think your work raises?
Well, I think I would merge this. Of course, this was a preliminary result. What I wanted to do is to use or to merge these future projections to an hydrological model in order to give more information on a basic level. So you can also calculate. I didn't have a look of ice bodies, of glaciers, I didn't make any projections of the glacier losses in the future, but I wanted to do that with more sophisticated tools and also on basin level. And we are lucky that we have the first national inventory of glaciers that counted every single glacier in all the basins from northern Argentina to the southern tip of Patagonia. So I think we have the chance to provide useful information for those aspects. So I think one of the open questions will be the impact in the glaciers, and for that I think we will have to use more sophisticated tools rather than just one global model, and we'll have to merge probably downscaled projections to feed maybe some hydrological model in order to provide more reliable numbers, not this kind of spread of percentages, but also more reliable numbers of the change.
Thanks, Juan. There's another question from Maria Eugenia de Porras. Great presentation, Juan. And the question is, do you think it is possible to manage summer precipitation water along with the decreased winter precipitation water in order to cover the water demand, and if this will be enough?
Okay, thank you, Maria Eugenia. Yes, what I didn't show because I focus on winter precipitation in terms of snow, but if we analyze summer precipitation, what model projections indicate is an increase, particularly in the lowlands of the region. So for me, it would be extremely hard to capture these kind of events because we are going. We have to think about the precipitation behaves in summer like isolated thunderstorms that is more or less difficult to capture the water from these levels in terms of the spatial heterogeneous distribution of these events. What the irrigation authorities here, what they do is they used to accumulate water in several reservoirs in the most relevant basins in the area. So what they do is to avoid releasing water for irrigation if the region had a significant amount of rainfall. For not from isolated storms, but from maybe frontal systems that provide more homogeneous rain in the region. But those kind of events are quite rare in the region, and I think you don't save much water doing that or avoiding the irrigation during those periods that might be 1 or 2 days before evaporation fluxes start to push for more demand of water for irrigation. So I think we start to, in my opinion, we have to start looking into the aquifers, to the groundwater, in order to see how much water do we have, what kind of quality do we have, in order to use this water for irrigation, because it's an enormous component of the hydrological cycle, and it's not widely known. So I think also this kind of storms in the summer might recharge the aquifers, and we have to start thinking about if this increase in summer precipitation projected by the global models will have some impact in the groundwater, and if this groundwater can be useful for the irrigation demands in the region.
Thanks, Juan. I do not see any further questions. I may have one more personal question about if you are aware of the impacts. I like a lot the wine in Mendoza, especially the Malbec. Do you know how the water resources changes that you show in your projections results will impact the production of the wine in Mendoza?
Yes. First of all, what I wanted to mention is that our institute, also researchers from our institute, documented a change in the organization of the vineyards. So people from the lowlands started or vineyards wineries in the lowlands started to decline, and it was an increase in the surface used by wineries in the region just close to the foothills of the Andes. So you can guarantee lower temperatures during the growing season, and you guarantee the access of water because they are just right there. So there was a displacement or a change in the spatial distribution of wineries over the last 30 years, and And of course, considering this, some researchers considering these projections in terms of precipitation and temperature, some researchers suggested that to keep the same quality of wine, uh, wineries will have to start moving southward to the southern portion of Mendoza, and also to the northern portion of Neuquén province in the northern Patagonia. And that area will be key for the wines of the future. But still, also have to play with the varieties, because when you think about Malbec, you're thinking about one type of wine that might be displaced by other kind of varieties like Cabernet Sauvignon, for instance. So it's quite complex, but I think the general idea would be if we are going to keep the wines as we have now, I think a southward movement of the wineries is projected.
Thanks, Juan. Now there's another question from Romina Rusica. Thank you for the talk, Juan. Do you know if the Argentina commitment to accomplish Paris Agreement have changed since 2016? You showed that in the Andes we are just on the critical year.
I think this year, 2020, should be the year that all the countries gather together and to push even forward to an improved mitigation target in terms of a reduction of greenhouse gases emission, which was in 2016, it was 18% reduction plus an extra 18 if Argentina received economical aid. But I don't really, I'm not in contact with the people that calculate this kind of stuff. So, but I am aware that, I don't know if because of the pandemic or any other problem, but this year should be the one that all the countries establish a new target for mitigation. And I think we have the impacts documented we are going, we're seeing even more record-breaking temperature levels in several areas of the world. So I think if we do not push hard for this emission reduction, I think that the critical years we are going even faster, even earlier in the future. So I think the countries must be aware that we are running out of time, that in the Andes there is a theoretical explanation I'm not going to make about the differential warming between the higher elevation and the lowlands, but with this example, with this study, I just wanted to illustrate this kind of stuff, that when you think of global warming from a global perspective, and when you calculate the global warming levels according to the Paris Agreement, we are seeing a global picture, and maybe the year could be 2030 or 2035, and you might think, well, the nations still have 15 years to do so, but several regions of the world, like the Arctic or the high elevations areas in the world, are seeing this target really coming close. So I think it's important to give a message to the decision makers in order to say that we are running out of time.
Thank you, Juan. Not sure, there is another question from Jason Gabriel Pinza. Not sure if I missed this during your talk, but do you have any insights on climate projections and upcoming ENSO cycles?
Hi, Jason. No, I'm not. I didn't have a look of that. I can rely on some publications by Kai that he projected an increase in the extreme events of El Niño and La Niña, but I'm not sure if I understood completely your question, but he this is relevant for the assessment of snow in this area of the Central Andes, because snow is really dependent on El Nino events. So it would be extremely relevant to have a decadal projection of some kind of short-term projection or short-term forecast of this kind of ENSO cycles, which will help also decision makers in order to aid or to forecast where we will have a snowy year, in order to, for instance, save water during dry years, or to build new reservoirs for the region. But I'm aware that yes, both ENSO and PTO has an enormous impact in the snowfall over the Andes, and I didn't have a look of the future ENSO cycles, but I think I'm aware of a probably increase in the extreme El Nino and La Nina events due to global warming.
Thank you, Juan. We are on the top of the hour, so and there is no more question, at least until now. So I would like to thank you again, Juan, for attending and giving this insightful talk. And I think it's really important that you are also trying to link the science with the stakeholders and its communication. So I would like to thank all the attendees, and please let me just advertise our next science webinar from this science webinar series that will be about the potential impact of COVID-19 emission reduction on climate. And the speaker will be Dr. John Fife. And the speaker will be presenting this talk on October 22nd between 2 and 3 p.m. UTC. In the chat box, Valentina has just pasted the link to register. So you are all very welcome to register and attend the next webinar. This will be recorded in the YES Community YouTube channel. So in case you have missed the first part, or you want to promote Juan's talk, you are very well, you're invited to promote it also from the YouTube recording. So thank you all, and have a nice day.
Thank you for the invitation.